Good morning to our beloved lecturer, Muhammad Sarhan, and my fellow friends. My name is Bellamy Mosley, metric number 05DAD19F1017. My group members is Jeffrey, Peterson, and Jamie Alvinus. We are from Group 8. We will be present about a car drag coefficient. So, let's go through the introduction and objective. The drag coefficient is a common measure in automotive design as it pertains to aerodynamics. Drag is a force that acts parallel to and in the same direction as the airflow. The drag coefficient of an automobile measures the way the automobile passes through the surrounding air. When automobile companies design a new vehicle, they take into consideration the automobile drag coefficient in addition to the other performance characteristics. Aerodynamic drag increases with the square of speed, therefore it becomes critically important at higher speeds. Reducing the drag coefficient in an automobile improves the performance of the vehicle as it pertains to speed and fuel efficiency. There are many different ways to reduce the drag of a vehicle. A common way to measure the drag of the vehicle is through the drag area. Drag coefficient CD are used to quantify the resistance of an object as it moves through a fluid. They are dimensionless quantity and allow aerodynamicists to account for the influence of shape, inclination, and flow conditions when calculating aerodynamic drag. Essentially, the more streamlined an object is, the lower its drag coefficient, whereas blunt and bulky object will have a high drag coefficient. Second is specification for vehicle model A, which is Proton Persona standard CVT 1.6 liter engine. So the wheelbase is 2.55 meter, length 4.387 meter, width 1.722 meter, and height 1.554 meter. The second vehicle model is 2020 Produa MyV 1.3 liter GMT. So the wheelbase is 2.5 meter, length 3.895 meter, width 1.735 meter, and height 1.515 meter. So the third vehicle model specification is Toyota Avanza 1.5e. The wheelbase is 2.655 meter, length 4.19 meter, width 1.66 meter, and the height 1.695 meter. So that's all from me. Thank you.
Conclusion. First is about vehicle model A is Proton Persona standard CVT 1.6 liter. The Proton Persona wheelbase is 2.555 meter. The length is 4.387 meter. Width is 1.722 meter. Height is 1.554 meter. The formula used is throttle area is 18% times length times width. Next is air density is 1.225 kilometer per meter. Next is drag coefficient. Table and answer for Proton Persona standard CVT 1.6 liter. The velocity first is 13.889 meter per second. The second is 22.222. The third is 30.556. The fourth is 41.667. Lastly is 15. Drag force use a symbol of Newton, N. Firstly is 62.435. Next is 100 and next is 159.834. The third is 302.186. Then 561.917. Lastly is 809.160. Frontal area is all same is 1.6.04064. Air density also same in use kilogram per meter 3 is 1.225. The drag confusion, the first one is 0.087477651. The second is 0.087481019. The third is the third is 0.087476679. The fourth is 0.087477962. The last is 0.087477931. Next is about graph velocity of Persona standard CVT 1.6 liter. Firstly, on 30.889 velocity meter per second is 0.087477765. The second is 22.222 meter per second is up to 0.087481019 and down to 0.087476679 on 30.556 meter per second, then up to 0.087477962 on 41.667 meter per second. The last is 0.087477931 on 15 meter per second. Next, about vehicle model B 2000 and next is vehicle model B is 2020 Pro2 Myvi 1.3 liter GMT. The length of Pro2 Myvi 1.3 liter GMT is 3.91 meter. The width is 1.76 meter. The height is 1.52 meter. The wheelbase is 2.5 meter. The air density is 1.225 kilogram per meter 3. The next is table and answer for vehicle B. The first velocity answer is 30.889 meter per second. The second is 22.222 meter per second. The third is 30.556 meter per second. The fourth is 41.667 meter per second. The last is 50 meter per second. Drag force use a Newton for ensemble. The first is 62.435. The second is 159.834. The third is 302.186. The fourth is 561.917. The last is 809.160. Rotor area for vehicle model B is the old ESM and use symbol M2 for is 5.50528. The air density also same and use symbol for kilogram per m per meter is 1.225. Drag coefficient, the first is 0.095984413. The second is 0.095988095.8. The third is 0.095983342. The fourth is 0.095924741.8. The last is 0.09598622006.
My name is Jeffrey and I will continue the presentation of calculation. The graph velocity of Perdua Mavi is at velocity 13.889 meter per second. The drag coefficient is 0.095984401 and increase at the velocity of 22.222 meter per second. The drag coefficient is 0.095988096. After that, at velocity 30.556 meter per second, it decreased at the drag coefficient 0.095983334 and increase at velocity 41.667 meter per second and 50 meter per second. The drag coefficient at 41.667 is 0.095984742 and the drag coefficient at 50 meter per second is 0.095986221. This is the calculation of Toyota Avanza 1.5e. The area I get is 5.56432. This is table from Toyota Avanza 1.5e. The calculation I get is at 50 km per hour. I get the drag coefficient is 0.0949679.614. At 80 km per hour, I get 0.09496 96179. At 110 km per hour, I get 0.0949649.068. At 150 km per hour, I get 0.094966299.4. The last kilometer per hour I get is at 180 km, I get 0.0949677.625. This is a graph velocity of Avanza 1.5e. The velocity at 13.889 meter per second. The drag coefficient is 0.094965961. Increase at velocity 22.222 meter per second. The drag coefficient is 0.094969618 and decrease at velocity 30.556 meter per second. The drag coefficient is 0.094964907 and increase at velocity 41.667 meter per second and 50 meter per second. The drag coefficient is 0.094966299. The drag coefficient of 50 meter per second is 0.094967763.
Hello, my name is Jamil Vinus. So me and my group member have been doing a discussion based on the data collected. Each vehicle has a different value of drag coefficient. This is mainly affected by each car frontal area. The graph of drag coefficient versus velocity meter per second shows that drag coefficient increase exponentially as its velocity increase. It also increased the standard test and measurement. So from the experiment that we made, we conclude that a very low drag coefficient automobile body can be altered to contain a walkable cooling system without increasing overall drag significantly. Drag coefficient is due to friction, pressure, and induced drag. The friction component is associated to the boundary layer development. Its magnitude depends on the characteristic of the fluid. So for the last one is reference. We got information from 5 websites, which is from Google, and also some of it from YouTube. Okay, thank you. That's all from me.